Surface Winds, Highs and Lows by 11DroushiotisSurfacewinds. What is surface wind? Surface wind is wind blowing at the surface of the earth. It is measured by convention at a height of 10 meters above the ground. It is measured at a standard distance above the ground to minimize the distorting effects of local obstacles in terrain. The wind is measured at a surface observing station by an anemometer. The picture depicts CN flags, which is a symbol used to indicate wind speed and direction. Throughout the images on my slideshow presentation, you will see these flags. What role does surface wind have in our atmosphere? Wind can be thought of as one way that the atmosphere moves excess heat around, directly or indirectly. Wind forms for the primary purpose of helping to transport excess heat either away from the surface of the earth, where sunlight causes an excess of energy buildup, or from warm regions, usually the tropics, to cooler regions, usually the higher latitudes. Wind is caused by air flowing from high pressure to low pressure. Since the earth is rotating, however, the air does not flow directly from high to low pressure, but is deflected to the right into the northern hemisphere, to the left in the southern hemisphere, so that wind flows mostly around the high and low pressure areas. The closer the high and the low pressure areas are together, the stronger the pressure gradient, and the stronger the winds. On weather maps, lines of constant pressure are drawn as the image shows, which are called isobars. These isobars are usually labeled with their pressure value in millibars. The closer these lines are together, the stronger the wind. Forces that cause and modify wind. Firstly, as gravity compresses the Earth's atmosphere, it creates air pressure, the driving force of wind. Without gravity, there would be no atmosphere or air pressure, and thus no wind. Pressure gradient force. The force actually responsible for causing the movement of air is the pressure gradient force. Differences in air pressure and the pressure gradient force are caused by the unequal heating of the Earth's surface when incoming solar radiation concentrates at the equator. Because of the energy surplus at low latitudes, for example, the air there is warmer than at poles. Warm air is less dense and has a lower barometric pressure than the cold air at high altitudes. These differences in barometric pressure are what creates the pressure gradient force and wind as air constantly moves between areas of high and low pressure. The Coriolis effect. Surface winds move from areas of high pressure to low pressure. The course of this movement is also altered by the influence of Coriolis force, causing the development of the trade winds. The Coriolis force and friction both significantly affect winds across the globe. Because of the Coriolis effect, winds traveling along the surface of the Earth from 30 to 60 degrees north and south of the equator flow from the west to the east. These winds are referred to as the westerlies. The air currents moving along the surface of the Earth from the poles 90 degrees to 60 degrees north and south of the equator flow from east to west, and these are referred to as the polar easterlies. The image on the right depicts a circulation. Centripetal force is a force that makes a body flow a curved path. In relation to wind, the centripetal force is responsible for a change in direction of the wind, not a change in speed. Friction will be explained in the next slide. Surface friction and its effects. Surface friction is the drag or skin friction of the Earth on the atmosphere, usually expressed in the terms of the shearing stress of the wind on the Earth's surface. The difference in terrain conditions directly affect how much friction is exerted. A calm ocean surface is pretty smooth, so the wind blowing over does not move up and down or around any features. However, in contrast, hills and forests force the wind to slow down and or change direction much more. The simple diagram shows just that. Where it is smooth, there is not many changes in direction. However, when the surface is rough, the wind changes and adjusts to move around the rough land. Surface wind in history. The highest wind speed ever recorded on the Earth's surface was 231 miles per hour on April 12, 1934, atop Mount Washington, New Hampshire. This high elevation weather station experienced the winds in an extremely strong jet stream that had descended unusually low into the atmosphere. Surface winds' effects on an oil spill. Firstly, spreading. Apart from chemical nature of oil, the extent of spreading is affected by wind, waves, and currents. Once a spill is thinned to the point that surface forces begin to play an important role, the oil layer is no longer continuous and uniform, but becomes fragmented by wind and waves. Evaporation. The composition of oil, its surface area and physical properties, wind, velocity, air and sea temperatures, turbulence and intensity of solar radiation, all affect the evaporation rates of hydrocarbons. And finally, oil spill control. Occasionally, the slick caused by a spill is removed through a controlled burn. Workers can burn freshly spilled oil with fireproof booms to contain the oil. However, burning only works under certain wind and weather conditions.